going to look at the different types of functions that can occur within algebra. There are three types of functions that we're going to be looking at primarily. The first function we're going to look at is what's known as a linear function. So notice the root word is line. So we're going to be looking at lines. All lines are functions, and the parent function for a line is y equals x. And due to the nature of this being a function, again, y and f of x are used interchangeably in terms of whether or not we got a function equaling x as well. So again, y equals and f of x equals the same. They are the same. Now, ordinarily, we're used to seeing for the equation of a line being y equals mx plus b. And we can, again, use y and f of x interchangeably as well. So this is all the same thing. Parent function, again, notice it is just x. So here we have the three different types of line. We got a diagonal going up, we have a diagonal going down, and a horizontal line. So key features, they are straight with no curves. And they always are going off in some sort of direction, either up and right, down and left, or straight across. Now, there is one exception to a line that would not be a function, and it would be a vertical line. And again, a vertical line is not a function because we have multiple y values for a single x value. So notice with this one, 1, 2, 3, this one is x equals 3. We have y equals 1, 2, 3, 4. In this case, for x equaling 3, there are multiple y values. So vertical lines are not a function. And the parent equation for a vertical line is x equals a number. And we don't know what the number is, but in this case, on our graph here as an example, it would be x equals 3. If I have an equation beginning x equals a number, we know it's a vertical line. Now, the next type of function we see is a quadratic function. And again, quadratic function, we have f of x, since it's a function, and it is x squared. So that's the parent function. The most common way that we see it is something times x squared plus something else times x plus a third number. So ax squared plus bx plus c. A, b, and c are just numbers that happen to be within the equation. The important bit is we have x squared. So in this case, we have the graph is curved, and they either open up or down. So here we open up because my arrows go off to the top. The other example, opening down since the arrows are pointing down. And the last type of function we're going to look at is exponential. So exponential function, f of x. In this case, x is the exponent, so some number raised to the power of x. And what it looks like is we have a gradual increase followed by steep increase. And the other way that it could go is we have a steep decline followed by a gradual. So again, we gradually increase and then we shoot up, or we come down and we level off for exponential. So depending on what it looks like, so if we have just x in our equation, we have a linear function. If we have x squared, we have a quadratic. And if x is the exponent, we have exponential. So if I were to look at these half dozen examples, the first one, 2x squared plus 3 equals 18. Doesn't matter what the equation looks like. As long as we look at our value of x, we can determine what it is. So linear, again, it's just x. X squared for quadratic, and exponential is some number raised to the power of x. So we have to see what's inside. First one, 2x squared plus 3 equals 18. We have x squared, therefore it is quadratic. 3 plus 5x being 20 is our next one. It's just x, so it's a linear equation. 3, we have 2a plus 3ax squared equals 24. we have x squared within our equation, therefore it is a quadratic equation. Number 4, 5 to the x equals 125. X being the exponent tells me we have an exponential. Number 5, 30 equals 6x minus 8, just x, linear. And then 6, 64 equals 4 to the x being the exponent, we have exponential. And then you can use these links to watch some videos. Number 7 here, we have this graph. We have to identify the parts representing linear, quadratic, exponential, and then state the domain and the range. So here we can see we have a whole bunch of different sections. So we have a section from 1 to 3, and then we go from 3 up to there, and then we level off. And from there to the top, and at the top we got a short section. We have a slight curve down to about there, and finally from about here to the tail end. So we got 1, 2, 3, 4, 5, 6, 7 different sections that we have to level up. So linear is pretty easy. As long as it's a straight shot, we can say that we have lines. So from 1 to 3, we're at linear. 3 up to 5, we're talking about a line. Horizontal, linear. Diagonal, linear. Straight across, linear. So this one's pretty easy. They're all straight. Anything straight would be a line. Now this part is just a curve. So as long as we're just curving and that's it, we're dealing with a quadratic section of the graph. Now the last section, we are decreasing in value and then starting to level off. So this part, that tells me this is an exponential section. So quadratic, we're just curving. Exponential, we're talking about a decline and leveling off in this case. So that is how we can tell the difference between quadratic and exponential. They both curve, but the exponential has the gradual piece to it, whether it's a gradual increase or a gradual decrease. Exponential will have that gradual leveling. Now the domain again is your x values. And again, x values are read left to right, so x versus y. So I want to go from my start to my finish. And I can see I go from 0 to 20. And again, it's all connected, so I'm using interval notation. I solidly hit 0, I solidly hit 20. So I'll use brackets. And then the range of the graph is bottom to top. So we have the bottom, and then I want to go to the top. And I can always use a line if we're unsure. Again, it is top to bottom of the graph. So it's not necessarily the starting and the ending point that I look at for the range. It's the bottom and the top. So if I look at my top here, I come across, I see it hit 8. So it is really 0 to 8. And again, everything's connected. So I'll use brackets since we solidly hit it. And that is identifying the type of function based on the equation and based on what is on a graph.